Hello everyone, welcome to another video. Let's do something a bit different this time. We'll use the KiwiSDRs for monitoring in the VHF aeronautical band. I know what you're thinking. The KiwiSDR is not made for VHF. It's a long wave through HF radio. How are we going to listen to aircraft in the VHF aeronautical frequencies? Well, I have found two sites on the internet that you can listen to that are using down converters. Thus, we can monitor the VHF signals and do it on equipment with all of the nice features and software in the KiwiSDR. Let's bring up a few notes and I'll take you into some details. The first of the two SDRs is located in Japan. It's in Saitama, operated by JP1ODJ. He's had this one up for a couple of years. It all started with a discussion in the KiwiSDR forums. This gentleman wanted all of the high performance of his Kiwi, but wanted to monitor the VHF aeronautical signals. Here's his picture. And here's the discussion. He also found the other one located in Russia. So he got it working on the VHF aero frequencies. He wanted to add wideband FM to access broadcasts. That was not going to happen because the KiwiSDR receiver slices are at most 20 kilohertz wide. That's just not going to work for FM broadcast. But you can see here he got it working and performance is good. Here is the architecture of the down converter receiver combination. He uses a disc cone antenna. The antenna feeds a signal through a bandpass filter, which is absolutely essential because it will pass the aeronautical frequencies and it will attenuate the FM broadcast signals below the airband, and it will attenuate a lot of the public service frequencies above the aeronautical band. Both of them contain potentially strong signals which can overload the next stage, which is the low noise amplifier. This stage is important because the sensitivity of the radio is determined by this first active stage. This is a low noise amplifier, so it will amplify the signals and not add much background noise. And in fact, it has a good noise figure on this station. My only gripe is that the gain seems high enough that there's a bit of intermod. We'll get into that later. The amplified and filtered signal is passed into a mixer. The oscillator signal, which goes into the mixer, is from this signal generator. He's able to precisely tune it to exactly where he wants it to be to produce the precisely tuned output fed into the KiwiSDR. In fact, this is a pretty stable signal generator. The output is accurate. The greatest error that I've seen has been about, 1 kilohertz or a little bit less than 1 kilohertz. So it's pretty good. Perhaps this is a bit of overkill because you can replace this large, expensive signal generator with a simple temperature compensated crystal oscillator or a GPS disciplined oscillator or a direct digital synthesizer with an accurate clock. Any of those can feed a clean, steady, accurate signal into here and mix with the aeronautical frequencies to produce precise output here for the KiwiSDR. So there is the architecture. So just for a bit of quick geographic orientation, looking at a map of the Far East. Over here is Japan, South Korea with 1 KiwiSDR, the People's Republic of China with a small smattering of Kiwis around Shenzhen and Hong Kong. I believe there's one up by Shanghai. And we've got a couple of them to the northwest as well. Vietnam has one KiwiSDR located in Hanoi. In the Philippines, I believe that's Mindanao, that has one. And then Japan with many, many Kiwis. Over here, there's Micronesia, the Northern Mariana Islands. Here's Iwo Jima down here, Iwo Jima, for you history buffs. And a chain of islands leading up to Japan and the main island of Honshu. Let's zoom in a little closer. The Kiwi that we're interested in is located near Tokyo. This is the Tokyo metropolitan area. Saitama is up here. JP10DJ has two Kiwis. This is the Airband Kiwi. Runs from frequency 118 to 140 megs. And the other one is a standard Kiwi with 0 through 30 megahertz coverage. I'm not going to click on it to bring it up from here because I've got some frequencies set up in the notes. Let's talk about the notes for a brief moment. We're using a KiwiSDR with a down converter. Down converting is a technique for operating VHF, UHF, and microwave with the features of your favorite HF radio. Hams have been doing this for many, many years in order to operate weak signal modes or some of the more performance demanding modes in moon-bound satellites, etc. A few suggestions for you when you're listening to these Kiwis that have the down converter. For the aeronautical frequencies, regular AM demod works best. If you are listening to a fixed frequency constant transmission like an ATIS, or if you're down in the navigation frequencies listening to a VOR or a localizer station, yes, you can use the Synchronous detector. The problem with using the Synchronous detector on the air traffic frequencies is that the different stations are not accurately zero beat on one frequency. You will see, if you look closely, that the controllers are on one frequency, the aircraft are above and below, and they are generally not dead on, and it's difficult for the Synchronous demodulator to track and lock onto those different carriers. As soon as one station drops carrier, another one comes on a slightly different frequency, and it takes time for the Synchronous detector to get that internal carrier in phase with the station that's being received. During that period of time, you'll hear a lot of noise, tones, squeaks that are rather unpleasant. So use the regular AM demodulator. On most SDR equipment, the envelope detector works very well and is superior to the old discrete component diode detectors. The band is noisy. Set your squelch to 2 to 4 dB in order to give you a bit of silence in between the transmissions. This is a sensitive receiver. The LNA has high gain. Unfortunately, there are some intermod products on strong stations. You will notice whenever there's a strong station, the spectrum will show signals plus and minus 594 and 693 kilohertz. That's above and below any strong signals that you're receiving, because there are two medium wave stations that are getting into the SDR equipment, and they're the ones producing these spurs at 594 and 693 above and below. Okay, let's talk about some of the signals that are on here. There are 3 ATIS frequencies which are readily available. The weakest one is in Tokyo, coming from Narita Airport. frequency 128.25. It's in the noise. It will occasionally come up out of the noise if there's a reflection from an aircraft. Probably during times of VHF enhancement, this will come up out of the noise as well. Tokyo Haneda is audible on 128.8 and Yokota 128.4. Now, I have these set up on the Synchronous detector because they're constantly on the air and they're steady in frequency. So it's entirely possible to listen, and they're not that strong. This one is especially not so strong. So the Synchronous detector does a bit of a better job. These other ones are okay. I believe Yokota has the strongest signal, and we'll still listen on the Synchronous detector. These are also set up, these URLs are set up to preset the frequency and the filter passband, -5 kilohertz and +5 kilohertz. So we're going to listen in a 10 kilohertz bandwidth to these AM signals. I do that because the defaults on a lot of SDRs are either too narrow or possibly too wide, depending on how the owner has set them up. I like to be very specific and choose my own filter bandpass. So I put it all in the URL, frequency, bandpass, mode. Click on it, and it comes up the way that I want it to come up. Tracon frequencies. Tokyo approach is on 119.1, 119.65. Tokyo departure 126.0. Those are frequencies with a lot of strong, clear traffic. En route frequencies that are coming in very well. Tokyo control on 120.5. Tokyo control 120.8, and the same call sign, Tokyo control on 124.55. This frequency is used by a lot of traffic proceeding to the south and east out over the ocean, and of course coming in from the ocean, from the south and east into the Tokyo area. The other SDR is located near Moscow, and I've got some frequencies set up. We'll listen to that later. 126375 for the ATIS, Moscow approach 122.7, and Sheremetyevo ground on frequency 121.8. This one does not have as much gain in the LNA stage as the Saitama SDR, but it works well. Okay, let's start with the ATIS over at Haneda Airport.
19 knots, maximum 30 knots, minimum 9 knots, direction variable between 210 and 280 degrees, visibility 10 kilometers, light shower rain.
So here we're listening in the Synchronous AM mode to the ATIS. Signal's okay, perhaps just a bit noisy. I want to show you one thing here before we go any further. There is a map which shows the area covered by Tokyo control and the various frequencies that are in use around Tokyo. 124.55 for some of the more distant oceanic traffic coming in and going out. 133.8 is used in this area here. And then we've got some other control areas which are not shown, no call sign shown. But this is the Tokyo control area here. Marked in black are different sectors and their various frequencies. Alright, let's check and find something else here. How about Yokota 128.4?
Tokyo International Airport Information Hotel 1022. ILS runway 22 approach and ILS Zulu runway 23 approach. Landing runway 2. Weather conditions, contact Yokota ground 308.6413 for weather and national information.
Yokota ATIS. I'm going to switch over to the envelope detector We'll stay with that for the rest of this video. Now notice down here there is a very weak carrier. Shows 128.365. That could be a spur, or it could be an actual signal. Here's another one. 128.25 approximately. That one actually is the Aegis from Tokyo Narita. Let's give it a try. Let's see what we can hear from Tokyo Narita Airport. So, this was a bit more audible earlier. It's really down in the noise right now. Not a chance. We can see the carrier, but I don't think we're going to hear any audio from that one. No joy. How about something strong? Tokyo Control. Tokyo Control 120.5. Things are rather quiet right now in Tokyo Control. 120.2 has a bit of traffic. Notice here, there is one transmission on 120.2. There's something very weak, a little bit above there. There we go. Somebody's home.
Tokyo Control, Orange Liner 529, leaving 5029, climbing 240. Orange Liner 529, Tokyo Control, climber maintenance 380.
120.5 is getting a bit more busy. Now, notice we have some strong signals here on 120.5. Above and below, there are these two carriers which appear only when we have a strong signal here. These are the intermod products. If you listen to these, what you'll hear is air traffic control or an aircraft, whoever's transmitting, and you will hear audio from an AM medium wave station. So I would say the owner-operator, ZP10DJ, would benefit from opening that radio up and putting in a bit better filtering to get those medium wave stations out. That way, when you have a strong signal, you won't have these intermod products. Notice here, there's another pair that's not from signals on this frequency. There is another frequency with some busy and strong traffic. Someplace down here. Let's stand by for a moment. There it is. On, 119 maybe 1191. Do I have that one? Let's take a look here. Yeah, 119.1, that's Tokyo approach.
Tokyo approach, Japan Air 218 approaching flight level 230, information India.
The coolest thing about these SDRs is we can just look at the waterfall and know exactly where the stations are. We know if it's a busy day at the airport. We know if it's not a busy day. We'll know if there's someone on a different frequency that we haven't found yet. It's a beautiful thing. Let's zoom in close and take a look here. Now, notice that all of these signals tend to be just a little bit below the exact point here where we would expect it to be. That's because the signal generator, which is feeding the mixer stage, is a little bit off. A little bit. Not much. Just a bit. And we'll see these carriers are not exactly zero beat with one another. They're all off a little bit. And to tell you the truth, they're all within the required specifications for the aircraft radios. They're all close enough. They don't have to be dead nuts on like the HF radios have to be. Now these two are pretty close. Look at that. They're pretty close. But there are some other ones which are farther off. Okay, so here's a look at some of the frequencies. What else is here? Let's switch over, visit this SDR over in Moscow. 126375 is the ATIS frequency over there. We'll kill this tab. Let this other radio render in our browser.
Турбулентность на предпосадочной прямой. При существенных изменениях. Сообщите получение X-Ray. Шереметьево АТИС. Информация для вылета X-Ray 10-30. 24. Центральная. Сухая. Сцепление нормативное 0,55. Эшелон перехода 120. Осторожно.
Here's the ATIS.
Погода. ВПП 24. Центральная. Ветер у земли 300 градусов, 6, порывы 11, условия хорошие. QNH.
The ATIS is a constant signal. It's entirely possible to listen to it on the Synchronous detector. No problem.
Турбулентность на предпосадочной прямой. При существенных изменениях. Сообщите получение X-Ray. Шереметьево АТИС. Информация для вылета X-Ray 10-30.
Now notice that this SDR does not have a lot of lines and hash from local noise around the receiver site. It's got this ATIS, which is a real signal. It does not have a lot of electrical noise and junk. My suspicion is that the LNA feeding the mixer is not a super high gain, low noise kind of device. It works well enough, but there's a lot of really low level background noise which is not showing here. It's okay, we are not plagued by intermod or other problems. Strong signals are still audible, no problem. Let's see what other frequencies are good. 122.7, Moscow approach.
Ветер у земли 300 градусов, 6, порывы.
Well, things appear to be pretty quiet over there right now. There's the signal. Once again, we see that there are some small differences in the exact frequency occupied by the aircraft and the air traffic controller radios. Well, there are some more dots in there. That's interesting. Notice the difference in frequency here. That's almost 2 kilohertz. So these are cool things you can do with the KiwiSDR that you cannot do with your typical scanner radio. Okay, so we've had a look at VHF monitoring on the KiwiSDR with the help of down converter technology. Talked a little bit about how it works. That covers the main topic I wanted to discuss with you here. I'm going to cut it. Hope you've enjoyed it. See you in the next one.